Hey, chemistry family, we are doing limiting reactants, and this is worksheet number 1 where we're going to start really predicting what is the limiting reactant and how much should be produced at the end. And to do that, we're just going to use all the reactants and convert to the same final product. Whichever reactant creates the least amount of final product, that is going to be how we determine, oh, that object, that reactant must run out first. So let's start with number 1. Identify the limiting reactant when 1.22 grams of oxygen reacts with 1.05 grams of hydrogen to produce water. So first of all, we're going to need a balanced equation because we're going to need stoichiometry to help us. So we know that oxygen and hydrogen are going to react, it said, so they're going to be the reactants. And it's going to produce water, which we know is H2O. Now that we have that bare bones equation, we are just going to need to balance it, which is a skill we've already learned. I've got 2 oxygens on the left, so I'm going to need a 2 there to get me 2 oxygens. That's going to make 4 hydrogens, so 2 times 2. I think that's going to be a 1-2-2 ratio in order to balance. Now that we have that, we know that you have this much oxygen and this much hydrogen. Think back to our s'mores lab. Think about the 2 ingredients. Which one is going to run out first? The one that runs out first is going to produce the least amount of product. That's going to limit the amount of product formed, which means it's the limiting reactant. Remember, reactants are on the left side of the balanced equation. All right? So now that we have that, all we have to do is 2 quick math problems to figure out how much mass of H2O do both of those produce. So I'm going to have both of these be my object A's, and water is going to be my object B. So let's start with the first thing we have. We've got 1.22 grams of oxygen, and we want to eventually solve for how many grams of water that will produce. We also know that we have the reactant 1.05 grams of hydrogen, and eventually we want to know, theoretically, how many grams of water that would produce. Remember, whichever one produces and predicts the least amount of product, H2O, that's how you'll know that that is the limiting reactant. So let's start with this one, step 1. We're going to go from mass A to mass B. To do that, I need to go from mass A to moles of A. So I'm going to divide by the molar mass, which is 32 grams of oxygen, oxygen plus oxygen on the periodic table. That's my step 1. Step 2, I'm going to go from moles of B to moles of A. My A is obviously my oxygen, what I started with, and I'm trying to predict how much water is being produced. So this is where I'm going to use my balanced equation. For every 2 moles of H2O, there's 1 mole of oxygen. And we know that because, of course, the balanced equation. We've done that in stoichiometry. And last but not least, I'm going to go from mole B to mass B. To do that, according to my mole map, for every 1 mole of H2O, there's a certain mass of water. Well, off the periodic table, 2 hydrogens plus 1 oxygen is going to give me 18.02 grams for H2O. Remember, that's hydrogen is 1.01, so add 2 of them up, plus oxygen, which is 16, and that gave you 18.02. Now that I have that, remember, in stoichiometry, I multiply the top, divide by the bottom. So it is going to be 1.22 grams of oxygen times 1, divided by 32, times 2, divided by 1, times 18.2, divided by 1. And what I end up getting for my answer there is about 1.37 grams of H2O, water. All right, now, if that ends up making less water than what hydrogen would, we'd know oxygen runs out first. But we have to do the math to figure that out. So let's do that. I'm going to go from mass of A to mass B again. To do that, first step is to go from mass of A to mole of A, which means I'm going to do 1 mole of hydrogen over its molar mass. And I know off the periodic table, 2 hydrogens is 2.02 grams. Now that I have that, I'm going to go from moles of B over moles of A, because I'm going to go from mole A to mole B. So use your mole map to do that. So my B object is going to be H2O. That's what I'm trying to find. And I'm getting rid of hydrogen, which is H2. Now, if I look on my balanced equation, Next to water is a 2. So that means for every 2 moles of water, there's going to be 2 moles of hydrogen. There's the 2, there's the 2. Perfect. So that's just stoichiometry review. Now that I have that, I'm going to go from moles of B to mass of B. So I need to put 1 mole of H2O on the bottom, according to the mole map, and then up top, I'm going to do the mass again of H2O. Now, I figured that out earlier in this problem, so I can just repeat that, 18.02 grams of H2O. Now, when I do that with my stoichiometry, remember I'm going to start with my number, 1.05, times the top, divided by the bottom, times 2, divided by 2, times 18.02, divided by 1. And when I do that, the answer I end up getting is 9.37 grams. Okay, so we did the math, but what does this mean? It means if we used all oxygen in the reaction, you'd get 1.37 grams of water. If we used all the hydrogen in the reaction, we'd get 9.37 grams of water. Well, obviously, one of them is going to run out first. And the one that runs out first is the one that predicts and produces the lowest amount of product. So since oxygen produced the lowest amount of water, we would say oxygen, O2, is the limiting reactant. So I'm just going to put O2 is LR. I'm going to circle that in red so you can see that answer. But remember, it asks you what is the limiting reactant. So the answer is oxygen is the limiting reactant. Even though we solve for water, it's asking not how much water would be produced, which would be 1.37, but we predicted how much water in order to get that limiting reactant. That's why we know the answer is O2. Oxygen is our limiting reactant. It produced the least amount of product. Just like our s'more lab, if you ran out of graham crackers first, graham crackers are the limiting reactant. They decide how much is at the end. Even if you got extra marshmallows and extra chocolate chips, it doesn't matter because you ran out of that one ingredient first. In this case, oxygen is the ingredient that runs out first, and that's why it's the limiting reactant. Looking at number 2, we've got identify the limiting reactant. So again, we're going to just look for, hey, which thing is going to run out first? So the limiting reactant we need to identify when 4.68 grams of iron reacts with 2.88 grams of sulfur to produce iron sulfide, and that would be iron 2 sulfide. So first things first, let's get our balanced equation. Iron is going to react with sulfur, which you're going to need to heat that up to make that happen. And that is going to make iron 2 sulfide. Perfect. Let's make sure we balance this up. And it looks like everything is going to be a 1-to-1 ratio. So that makes that easy for us. Now that we have that, we just got to figure out, is 4.68 grams of iron going to run out first or 2.88 grams of sulfur? Well, let's do it. Take what we have. I've got 4.68 grams of iron, and I also have 2.88 grams of sulfur. I know I'm going to do a mass-to-mass problem, so let me just write in my 3 steps right away so I don't forget any. And remember, the idea is that I got to figure out how many grams of FeS am I going to produce at the end. No problem. Let's do it. Step 1, to go from mass of A to mole of A, I'm going to take the mole of the object, A, which is iron, and divide it by the molar mass. On the periodic table, iron is 55.85 grams, so I'm good there. Next thing I'm going to do is go from moles of A to moles of B, which is going to be B over A moles for my conversion. To do that, I'm going to look off the balanced equation. B is my object that I'm going to end in, right? FeS, that's my B, so I know from the balanced equation there is 1 mole of FeS for every 1 mole of Fe. FeS is, again, iron 2 sulfide. Fe is iron. And let's go from there. Now that I'm in mole B, I'm going to go from mole B to mass of B. So I need to put 1 mole of the product on the bottom, object B, which is iron 2 sulfide. And then on top, I'm going to put the mass of iron 2 sulfide, which is adding together an iron and a sulfur. Adding those up, I get about 87.92 grams of iron 2 sulfide. Now let's do our math. Remember to take the number you start with, multiply by the top, divide by the bottom, multiply by the top, divide by the bottom, multiply by the top, divide by the bottom. When I crush that into my calculator, what I end up getting is about 7.37 grams. 7.37 grams of FeS. Okay, well, if that ends up being less of iron 2 sulfide than what sulfur would produce, I know that my iron will be my limiting reactant. But let's see if that is the case. So now I need to go to this one. 2.88 grams of sulfur. I'm going to convert that into moles of sulfur. So I'm going to put 1 mole of sulfur on the bottom, or the top, for every certain amount of grams of sulfur. I'm going to look on the periodic table. There's about 32.07 grams of sulfur for every mole of sulfur. Now that I'm doing that, I'm going to go from moles of A to moles of B. So I'm going to do B over A moles. Sulfur is going to be on the bottom. My product, the thing I'm solving for, is my B object. That's going to be on top. That's iron 2 sulfide. Looking at my balanced equation, everything is a 1-to-1 mole ratio. So there's going to be 1 mole of iron 2 sulfide for every 1 mole of sulfur. And my last step will be identical to the one just above it. For every 1 mole of iron 2 sulfide, if you add up iron and sulfur off the periodic table, it's going to be 87.92 grams of FeS. As always, for stoichiometry, I'm going to take my first number, 2.88, multiply by the top, divide by the bottom, multiply by the top, divide by the bottom, multiply by the top, divide by the bottom. Now, if I'm going to crush that in my calculator, I end up getting about 7.9 grams of FeS. Now that I've converted both of my reactants into product, whichever one creates less, must have come and been predicted from the limiting reactant, the one that runs out first. In this case, the least amount of product is the top one with 7.37 grams of iron 2 sulfide. That's how much we would expect to be produced of the product, but that means that iron is my limiting reactant. So since the question asks for what is the limiting reactant, we would say that iron is the limiting reactant, or RL for short. There you go. I proved it because iron creates the lowest amount of product, and we know the limiting reactant is the thing that limits how much product is created. And there you have it, friends. That was questions number 1 and 2 from your limiting reactants. Keep going. There's other videos available if you'd like to keep getting that support.